In this example, we are given 0.100 molar HCN solution, and we're also given its pH, which is 5.20, and we are asked to find the pKa and the Ka values. Now, since we're given pH of 5.20, we can say that pH is equal to negative log of H plus, which can give us our H plus concentration. So we can say that our H plus concentration is going to be 10 to the power of negative pH. Now this is because we know that if log of A base B is equal to n, A to the power of n will be equal to B, which is basically what happened here, because since we're not given a base here, we take it as 10, so it's going to be log 10 base H plus is equal to our pH, so 10 to the power of negative pH is our concentration of H plus. So the concentration of our H plus ions is going to be 10 to the power of negative 5.20, which is equal to 6.3 times 10 to the power of negative 6 molar. Now, since we're dealing with weak acids and bases here, we're going to use the ice table as our solution. So to start off, we rewrite our equation, or write our equation. We have HCN dissociating into H plus and Cn minus. Initially, we're given 0.100 molars of HCN. We're going to say that we didn't have any H plus in the first place because it's not given in the question. The same goes for cyanide. For the change conditions, we're going to have negative X, and positive X. Next, for the equilibrium concentrations, we're going to have 0.100 minus X for HCN. For H plus ions, we're going to get X, and for cyanide ions, we're going to get X as well. Now, according to question, we already figured out the value of X, which is the concentration of H plus, which is 6.3 times 10 to the power of negative 6. So we can say that according to question, X is equal to the concentration of H plus, which is equal to 6.3 times 10 to the power of negative 6 molar. Therefore, the concentration of HCN will be equal to 0.100 minus X, which is equal to 0.100 minus 6.3 times 10 to the power of negative 6 molar. Now that is going to be equal to 0.0999937 molar. Now, since cyanide's equilibrium expression was also equal to X, so we can say that cyanide's concentration was the same as that of our H plus concentration. Now, we still have to find our Ka value and our pKa value. So what we can do is that we can use the equilibrium constant or the acid ionization constant to figure out the value of it. So we know Ka is going to be equal to the product of H plus and concentration of Cn minus over concentration of HCN. The value of all of these we already have. So we can plug them in and we get our K value equal to 6.3 times 10 to the power of negative 6 times, once again, 6.3 times 10 to the power of negative 6 molar squared, because we have two concentrations, divided by 0.0999937 molar. And we end up with a Ka value of 3.97 times 10 to the power of negative 10 molar. Now all we have left to find is the pKa value now. Now we all know that pKa is equal to negative log of Ka. We already have our Ka value, so we can plug that in, and we will get negative log of 3.97 times 10 to the power of negative 10, and we end up with a pKa of 9.40, which is our second answer other than our Ka value. Let us now look into a different type of acid-base example.